class 10 physics, work, energy and power, and we'll do the section conservation of energy. So the law of conservation of energy states that energy can neither be created nor can it be destroyed. So this means we cannot create any new energy and we cannot destroy the energy which is already exist. Okay? And the second one, it changes from one form to another. Energy always changes from one form to another. A simple examples we can take: when we switch on the bulb, the electrical energy converts into light energy. Okay, and if you switch on the geyser, again electrical energy converts into heat energy and the water will get boiled. Okay, so in the kitchen, if you see that if you on the gas, that at that time chemical energy converts into heat energy and the food will get cooked. Okay, and there are many other examples also, but everywhere we see that energy is changing from one form to another, and total amount of energy remains constant in the system or universe. We know that in universe there are various forms of energies. Okay, and all those energy always transfer from one form to another, or it changes from one form to another. While changing those energy from one form to another, the sum of all the energies in the universe remain constant, or it remain conserved. Okay, that is the law of conservation of energy. In simple words, we can say that law of conservation of energy states that energy can neither be created nor can it be destroyed. It can only be transformed or changes from one form to another. For the conservation of energy, as per our syllabus, we will do conservation of mechanical energy. Okay, in simple words, the energy possessed by a body due to its rest or motion is a mechanical energy, and mechanical energy we have in two forms. One is your potential energy and the other one is your kinetic energy. Potential energy is due to its rest or position, and kinetic energy is due to its motion. Okay, so energy possessed by a body due to its rest or position is a potential energy. Energy possessed by a body due to its motion is a kinetic energy. These are the simple definitions for the potential energy and the kinetic energy. Okay, if there is only interchange between the potential energy and the kinetic energy, ignoring all the external forces, the sum of the potential energy and the kinetic energy, the sum of potential energy plus kinetic energy will always constant. Okay, ignoring all the external forces. Okay, so sum of potential energy and the kinetic energy is constant, and this sum of potential energy and kinetic energy is nothing. This is your total mechanical energy. So that means when there is an interchange of potential energy to kinetic energy or kinetic energy to potential energy only, the sum of the potential energy and the kinetic energy will remain constant. That means that is the total mechanical energy is always constant or it is conserved. That is your conservation of mechanical energy. Let's understand this with the example of a freely falling body. If we allow a body to fall freely, okay, under the force of gravity, initially the speed of the body, so let's take this position as A and the ball falls to this position, let's take this position as B. Initially at B, the speed of the body will be 0. Initially U will be 0. When the speed of the body will be 0, it is falling vertically downwards, so its velocity will be 0. When the velocity is 0, its kinetic energy at position A will be 0, since kinetic energy is equals to half mv square. When v is 0, entire term will become 0. So at A, when there is a velocity 0, kinetic energy will be 0. Okay, and as the body falls downwards, the velocity of the body increases. Okay, the velocity of the body increases, and before touching the ground, the velocity of the body will become maximum. When the velocity of the body will become maximum, here kinetic energy will also be maximum. Clear? Okay, now at position B, the kinetic energy is maximum. So if we check the potential energy here, potential energy, okay, the ball is falling from height is, okay, so here the height at A, height is h is maximum. When the height is maximum, potential energy is maximum. Okay, at A, potential energy is maximum. As the height decreases, potential energy will also be decreases, and here the height will be 0. At that time, potential energy will be 0, since potential energy is equals to mgh. It depends upon the position, height. So when the height is maximum, potential energy is maximum. When the height is 0, potential energy is 0. So when the velocity increases, kinetic energy increases. So here if you see that, so here potential energy is maximum, here is 0. So where did this potential energy go? So here this maximum potential energy is changing into the kinetic energy. So here also sum of potential energy and the kinetic energy is constant at every position here. At every point, if you find, the total mechanical energy will be same. That means the sum of potential energy and the kinetic energy will be equal. So what we have observed here, when the velocity of the body increases, kinetic energy will also be increased. And when the height decreases, potential energy decreases. So here, when the ball falls downward, or when the body is moving downwards, the potential energy is decreasing and the kinetic energy is increasing. That means there is an interchange between the potential energy and the kinetic energy. Clear? So from here, we can get one equation which is very important here. So if, let's take that mechanical energy at A is equal to, here the potential energy is maximum, kinetic energy is 0. So here the total mechanical energy is maximum at point A. And if we see the point B, the sum of the potential energy and the kinetic energy, potential energy is 0, kinetic energy is maximum, so the total mechanical energy at B will be maximum. So that means total mechanical energy at A is equal to the mechanical energy at B. Mechanical energy at B. So from here we can say that potential energy at highest point, highest position is equals to kinetic energy at lowest position. So from here we have to understand potential energy at highest position or the highest point is equals to kinetic energy at its lowest position or lowest point. To understand this concept clearly, let's do one example, and this kind of questions are there in the ICC examination, okay, in the previous years. Okay, if there is a body of mass 500 gram, okay, falling from a height h is equals to 5 meter. So this is position A, this is position B, and we have to find the kinetic energy at B. This kinetic energy at B we have to find. So we know that kinetic energy formula is a half mv square. the kinetic energy is equals to half mv square. We have mass but we don't have velocity. So from this we cannot find the kinetic energy directly. Okay, so we can see here this, but we know the concept that potential energy at highest position is equals to kinetic energy at its lowest position or lowest point. So if we find the potential energy at A will be equals to kinetic energy at B. So here let's see, we can find the potential energy or not. Potential energy is equals to mgh. H is given, m is given, and g is always constant, which is 9.8 meter per second square, or approximate value we can use, that is 10 meter per second square. We can write here, okay, mass is equals to 500 gram. So we have to convert this into SI unit. 500 gram can be written as 500 divided by 1000 kg. This can, get cancelled. This will be 5 divided by 10 kg. Clear? So here, and h is given 5 meter, and z is approximate value is here 10 meter per second square. Now by the conservation of mechanical energy we can write here kinetic energy at B is equals to potential energy at A. Okay, since kinetic energy at highest position or highest point is equals to potential energy at its lowest point. Okay, so potential energy at A will be how much? mgh. This is equals to how much? M is here 5 divided by 10 kg into g is here 10 meter per second square into height is here 5 meter. This 10 get cancelled. Here 5 are 25 kg meter per second square is here Newton, and meter is here 25 joule. So kinetic energy at B is here 25 joules. In this kind of question, if we don't have the velocity also, we can find the kinetic energy with the relation potential energy at highest position or highest point is equals to kinetic energy at its lowest point or lowest position point. Let's do the verification of conservation of mechanical energy. Conservation of mechanical energy is nothing. Potential energy plus kinetic energy is constant. And for a freely falling body. So let a body of mass m is falling freely from a height h, okay, above the ground under the force of gravity. So from position A, okay, and when the ball falls or a body falls from position A, its potential energy changes into its kinetic energy, and the sum of potential energy and the kinetic energy at each instances will remain constant, will be that means total mechanical energy will be same. Okay, so in order to prove this, let's find the sum of potential energy and the kinetic energy in 3 positions. Okay, let's take these 3 positions A, B and C. Here the height here A to C is here h, and this much height A to B let's take as x, and this height will be h minus x. Okay, so first we'll do at position A. So at position A, our potential energy will be maximum, that will be mgh, Okay, we don't have to convert anything. Mass is m, g is the acceleration due to gravity, and h is the height, maximum height. Potential energy will be mgh, and kinetic energy will be half mv square, half, okay, m. So here initially when the body will fall, speed will be 0, so here the velocity will be 0. Since the velocity is 0, the kinetic energy will be 0. Therefore total mechanical energy at A is potential energy at A, potential energy kinetic at A plus kinetic energy at A is equals to mgh plus 0 is equals to mgh. At position B, potential energy is equals to mgh is equals to mg. Here height at B, the height is how much potential energy? For potential energy, h is equals to this much. Height is here h minus x. This is equals to mgh minus mgx by opening the bracket. And for finding the velocity, so we have to use the equation of motion, third equation of motion, by the equation of motion. Okay, v square is equals to u square plus 2as. Okay, so the body is falling from here, so initial velocity here is 0, the final velocity is v. So anyways, and the distance covered here is x, distance s is equals to x, and a, acceleration due to gravity, a is here z. So here u will be 0 plus 2, a is here g, s is here x is equals to 2gx. So therefore kinetic energy at B, potential energy at B and the kinetic energy at B is here half mv square. This is equals to 1 by 2 into m into v square is here 2gx. 2 will get cancelled. This will be mgx. Therefore total mechanical energy at B is equals to potential energy at B plus kinetic energy at B. This is equals to potential energy at B will be mgh minus mgx plus mgx. Kinetic energy at B mgx. This get cancelled is equals to mgh. So from here we can see that total mechanical energy at A is equals to total mechanical energy at B. Okay, similarly we find for at position C. So here potential energy is equals to mgh. When the body reaches at position C, here h is equals to 0. So here height will be 0, mg into 0 is equals to 0. Potential energy will be 0. And for kinetic energy, again we have to know the velocity. So by the equation of motion, okay, v square is equals to u square plus 2a is here. Initial velocity again is 0. The body is traveling from A. Initial velocity is 0. Here the body will cover maximum distance h. 2a will be here z, s will be here h is equals to 2gh. Therefore kinetic energy at C will be how much? Half mv square is equals to half into m into 2gh. This cancel is equals to mgh. So therefore total mechanical energy at C is equals to potential energy at C plus kinetic energy at C is equals to 0 plus mgh is equals to mgh. Okay, if you notice, the total mechanical energy at A, B and C all are same. Okay, this is the verification of the conservation of mechanical energy for a freely falling bird. Okay. Next we will do the verification of conservation of mechanical energy for a motion of a simple pendulum. Okay, I have a diagram of a simple pendulum. So pendulum here, A is the mean position, or it is in a resting position. From here, if you oscillate, B and the C are the extreme position. Even C is the extreme position. Okay, when the bob will oscillate at B and the C, the bob will be at its maximum height H. Okay, so when the bob will move from A to B or A to C, kinetic energy converts into potential energy, and when it will move from B to A or C to A, potential energy converts into kinetic energy, and each instances or at every point the sum of potential energy and the kinetic energy will be constant. So that is the conservation of mechanical energy is potential energy plus kinetic energy is equals to constant. Okay. To verify this, let's find the sum of potential energy and the kinetic energy at position C, A and B. So at position C, here potential energy at C is equals to how much? mgh. So here the height at C is h maximum, so it will be mgh, and kinetic energy here will be how much? Let's see. Kinetic energy at C is equals to half mv square. Okay, this is a half m. So here when it will reach at position C, extreme position, the bob will stop for a moment. When it will stop, the bob will be at rest. When it is at rest, its velocity will be 0. At this position, v is equals to 0. So when the velocity is 0, so kinetic energy will be 0. Therefore, total mechanical energy at C is equals to potential energy at C plus kinetic energy at C is equals to how much? mgh plus 0 is equals to mgh. Clear? And at position A, potential energy is equals to mgh. So here if you see that at position A, it is just above the ground. It is before touching the ground. Here h will be 0. At this position h will be 0. When the h will be 0, your potential energy at A will be 0. Potential energy at A will be 0, and if you have to find the kinetic energy, we have to find velocity is how much first. For velocity to find for the moving body, we have to use equation of motion. By equation of motion, we get v square is equals to u square plus 2as is equals to, here u initially it is coming from C or it is coming from B, is 0 plus 2. A is your maximum, that means A is the acceleration due to gravity G, and here it is covering a maximum distance S, so that means it is coming from height H. So this will be your h, height s, distance will be h is equals to 2gh. Therefore, kinetic energy at A will be half mv square. This is equals to half into m. V square is here nothing, 2gh. These two get cancelled, is equals to mgh. Therefore, total mechanical energy at A is potential energy at A plus kinetic energy at A is equals to, potential energy will be 0, kinetic energy will be mgh is equals to mgh. Clear? And at position B, position A and the position B will be same. Okay? So, sorry. Position B and the position C will be same because they both are in the extreme position. Even though we will find here, here potential energy at B is equals to mgh. Here the height is maximum, again this will be mgh only. There will be no changes. And kinetic energy at B will be how much? Here at B again the velocity will be 0. So here this will be here K is here half mv square is equals to 1 by 2 m, velocity is 0 is equals to 0. Therefore, total mechanical energy at B is equals to potential energy at B plus kinetic energy at B is equals to mgh plus 0 is equals to mgh. So here also we have found that the total mechanical energy at position C, A and B are same. So that means here the energy is being conserved. The sum of potential energy and the kinetic energy is same. So we have noticed there in the maximum height here at this position, so when the bulb will move from A to B, the height will increase. When the height increases, potential energy will also be increased. And when it is coming from B to A, the height decreases, that means its velocity will increase here. So when the velocity increases, the potential kinetic energy will also be increased. So at A, kinetic energy is maximum. And at C and B, potential energy is maximum. Here also potential energy is maximum. And here kinetic energy is 0 since the body is at rest, no speed. So here since the height is 0, potential energy is equals to 0. So we have noticed that for a motion of a simple pendulum at extreme position, the potential energy will be maximum and the kinetic energy will be 0, and at its mean position, kinetic energy will be maximum and the potential energy will be 0.